Hey students, these are slides 24 through 28 on Tuesday, 2/23/21 Desmos. It was the homework that was attached at the end of the Desmos. And what we're doing here is we're looking at these and determining, are they arithmetic, are they geometric, or are they neither? Remember, if they go up by some multiple, right, if you multiply by a whole number or a fraction, they're geometric. If you add or subtract the same number each time, they're arithmetic. And if neither of those work, they are neither. So let's walk through here. Number one, we're going from 1 to 5, 5 to 25, 25 to 125. So can you see right away you can't add the same thing? If you can see that, awesome. If not, you can check another way. What if you can multiply 1 times something to get to 5? And then that same thing works all the way through, you're good to go. So if you can find that, great. If not, this is another way to look for that common ratio or growth rate. Take one of these terms, divide it by the one previous. So what's 25 divided by 5? All right? Well, 25 divided by 5 is 5. Well, then do it with two other numbers, right? Let's try another set. Take another number, divide it by the one previous. You might need a calculator for this one. 625 divided by 125. Go ahead and do that on a calculator. Well, it's also 5. So that means that this is a geometric sequence because it has the same ratio, right? A common ratio, we're calling it that. I can't remember what we're calling it too. So geometric sequence with a common ratio and that growth rate, right? That growth rate of 5. So it's geometric. Let's go ahead and look at this next one then. 40, 43, 46, 49. It doesn't look like it's growing too quickly, so let's see if there's something we can add or subtract. 40 to 43, 43 to 46. Again, you can use this same idea, 43 to 40. You could divide it or you could subtract it and see what happens. I can see that it looks like it's increasing by 3, right? So hopefully, let's see if does that work on the next one. 43 plus 3. Yep, that's 46. So we're going up by 3 each time. That means it's arithmetic with a rate of change of 3. Ooh, 3 is a tough one. I saw a lot of people make some mistakes on this from people who already completed the homework. 4 to 13 over 3 to 14 over 3 to 5 to 16 over 3. And so a lot of you see a fraction and you just say it's geometric or neither. But what if I rewrote 14, right? I could rewrite that as 12 over 3, right? 12 divided by 3 is 4. So now do you see a pattern here? 12 over 13, 14 over 13. 5 I could write as 15 over 13. And 6 I could write it, and then the last one was 16 over 3. So it's 12 over 3, 13 over 3, 14 over 3. And so we're adding 1/3 each time. Or we're adding the same number each time. That means this is arithmetic. I know it was a tough one, but you got this in you. All right, I'm going to exit out of this. So if you need to write those down, write them down and then keep going. Let's look at 4. Negative 4 to 12, 12 to 36, 36 to 108. I can see I'm not adding or subtracting the same thing because it's bouncing back and forth between negative and positive. So right away I know it is not arithmetic. To see if it's geometric, let's test a couple of these. Do I know negative 4 times something is 12? I could just divide 12 by negative 4, and that's negative 3. All right, if it works for another set, then we know we have our constant right here. So let's go 36 divided by 12, and that's negative 36 divided by 12, and I also get negative 3. You could keep testing this, or you could just start to multiply. Negative 4 times negative 3 is 12. 12 times negative 3, negative 36. Negative 36 times negative 3, 108. Right, so our growth factor there is negative 3. That means this is geometric. All right, 2 more left. Go ahead if you want to try these out on your own. 4 to 16, 16 to 36. All right, so I'm going to test a couple of things here. It looks like it's a multiplier. So 4 times what is 16? 4 times 4. All right, 16 times 4, is that 36? 16 times 4. 16 4. Is that 36? Go ahead and check that out. It doesn't seem right to me for some reason. No. 16 times 4 would be 40 plus 24 would be 64, right? If I multiplied, so that doesn't work. All right, let's try adding. 4 plus 12, that gives me 16 plus 12. Does that give me 36? 20, that'd be 28, so no, that doesn't work. So multiplying or adding doesn't work for increasing, so this is definitely neither. All right, this is neither. And in fact, this is a sequence that goes 2 squared, 4 squared, 6 squared, 8 squared, 10 squared. So it's even numbers squared. Fun little pattern, but it's not geometric or arithmetic. And finally here, negative 29, negative 34, negative 39. So that looks like it's going down, but by how much? From 29 to 34, negative 29, negative 30, 31, 32, 33, 34. So that is going down by 5. Let's see. Subtract 5 again, 34, 35, 36, 37, 38, 39. Yeah, there it is. So it's going down by a constant rate, right? That rate of change is negative 5. And so this means it's arithmetic. All right. Watch that again if you didn't follow. Join us in office hours when you need to. This is one of the main skills we need to pull out of this chapter, is just determining if they're arithmetic or geometric. All right, so let's move to this next one. We got to figure out, is it arithmetic or geometric? All right, and then we're going to write a function. So if we look at this, it looks like I'm going down from 14 to 6, 6 to negative 2, negative 2 to negative 10. And it's not going very quickly. And so I'm going to guess that this is arithmetic, but let's double check. 4 to 6, that would be minus 14 to 6 minus 4 is 10, minus 4 more, so that's subtract 8. Does that work there? Yep. All right, so I found my rate of change is negative 8. All right, and then my initial value here, right, the y-intercept is 14. So my function follows the form mx plus b, right? My rate of change in a linear function's there. My initial value is right here. So I'm going to say f of x equals negative 8x plus, it starts at 14. All right. Ooh, let's look at this one. 1 to 9 to 81 to 729. That's going up so quickly, it's got to be geometric, right? So let's look. 1 times what is 9? 9 times what is 81? Times 9. Do you see that? That it's multiplying by 9? If not, remember you can divide 9 by 1. I get 9. Divide 81 by 9. I get 9. Divide 729 by 81. You get 9. So you can do it two ways, right? Divide a number by the previous, or look at how to multiply. And so my growth factor here is 9. My initial value comes right here from x equals 0. And so that's 1. So how do I write this equation? F of x is equal to my initial value times the growth factor to the x power. And again, look for that formula. This is sloppy. I'm not going to write out all those words. So f of x equals my initial value of 1 times the growth factor of 9 all to the x power. Exponents in the variables in the exponent, thus an exponential function. Here we go. We're cooking with dynamite now. 2 left. Ooh, this sequence. From 1 to 1/2. 1/2 to 0. 0 to negative 1/2 to negative 1. Well, if I multiply by a fraction, 1/2 times another fraction is going to give me another fraction. So it can't be geometric. So let's see. How do I go from 1 to 1/2? I'm going to subtract 1/2 each time. If I do that 1/2 minus 1/2, I get 0. Okay, that works. Minus 1/2 again, I get negative 1/2. Subtract 1/2 again, I get negative 1/2. So my rate of change, right, in this linear function for an arithmetic sequence is negative 1/2. let's see where else we can go. All right, now I need my initial location. And so, since this is a sequence, right, we have our first term. We need to go back one more for our first term, right? So this is our t equals 1, right? We need to say, what is our initial value? So that's going to be 1 1/2 or 3/2. All right, you can write it either way. And so this function is f of x. My rate of change is negative 1/2. Looks like a lot like the slope, right? Same idea. And where are we starting on it? At 3/2. You could have written it this way. A lot of you like Desmos, so here's one more way. Negative 0.5x plus 1.5. Exact same functions, one with fractions, one with decimals. All right, let's finish this off. Here, we're starting at 1. All right, we're going 1/3, negative 1/9, 1/8. And so I made this problem, and so I made a mistake. This should have been our first term. All right. And so let's imagine this. Our initial value is 1. We're going up by a rate of change of 1/3 because 1/9 divided by 1/3. You can go ahead and do that in your calculator. You're going to get 1/3. And you can do each of these. But I say 1/3 times 1/3 is 1/9. Times 1/3 is 1/81. And so our rate of change, or our growth factor, or our common ratio or growth factor is 1/3. So I'm going to write the function or f of x is our initial value times 1/3 times the x power. Now, if I was doing this different, right, if I was saying, oh, this is the first term, to find our initial value, and this is, stop listening if I'm confusing you already, but if I would have to multiply by, I'd have to divide by 1/3, so I'd actually have an initial value of 3 if you wanted to do it as is written. So this is where we're going next week, right, where we have initial values that aren't 1. And so if I wanted to solve it as it was written, I could write it as this: 3 times 1/3 to the x power. All right. So either one of these will be acceptable. This is what you're going to be assessed on Thursday, is when you have initial value of 1. All right. If you have questions, email me or your teacher and let us know how we can help. All right. Have a great night. Have a great day. Be ready to show your knowledge tomorrow.